Like the little engine that could, NASA's Curiosity rover has been bravely crawling over Gale Crater on Mars, trying to see what could have happened billions of years ago that made the planet a red desert. And it looks like it might have finally stumbled upon something. While life seems impossible on Mars now, eons ago, it may have been a world more like Earth, with a thick atmosphere, water, and maybe even life. And it seems things changed just recently. Studies show that just 3 billion years ago, the northern hemisphere of Mars might have hosted a stable ocean. On Earth, the Archean eon was in full swing. Volcanoes were going crazy, and life was taking its first steps. Life was also perhaps taking its first steps on Mars. No, not a frozen wasteland like Antarctica, but in a body of water like an Earth ocean. And this Earth-like climate extended Mars's habitable period by about 500 million years more than we thought before. In other words, there was a 500 million years where it was exactly like Earth, with conditions just right for life to start forming. But then, something happened that changed things forever. The atmosphere thinned, Mars lost its oceans, and became the cold, desolate place we see today. It's been a mystery for a while, but now, Curiosity stumbled upon something interesting in the Gale Crater. A vast basin on the Martian surface where, billions of years ago, water once flowed freely. It found carbonates, stuff that can tell us all about the ancient Martian climate. There are minerals that form when carbon dioxide, or CO2, dissolves in water, which means that, to create them, you need two things: a nice thick atmosphere and liquid water. Now on Earth, CO2 is super important because it helps trap heat from the sun in our atmosphere. This keeps our planet warm enough to support life. Plants eat it during photosynthesis to create oxygen, which humans and animals need to breathe. On Mars, the presence of CO2 shows that there really was some kind of climate system. When CO2 starts dissolving in water, it reacts with certain minerals in the ground, like calcium or magnesium, and creates carbonates. That's kind of how seashells form in oceans here on Earth. But instead, it's happening with rocks on Mars. And this discovery is huge. These carbonates act like fossils of the planet's ancient climate. They store information about what Mars was like long ago. By studying them, scientists can get a peek into Mars' past back in the day when water was present. They can tell us how the Martian atmosphere has changed over time, show whether the atmosphere was warm or cold, or if there was a lot of water around, and what happened to the planet in general. Luckily, Curiosity can study this stuff right there. It has the sample analysis at Mars and tunable laser spectrometer. Those are like Mars's forensic tools. The SAM is a mini lab on wheels, and is capable of heating Martian rock samples to extreme temperatures. There are two ovens that can heat samples to about 1,800 degrees Fahrenheit. This intense heat causes rocks to release gases trapped inside, the ones that are like ancient fingerprints of Mars, atmosphere. Once they're released, the TLS analyzes them in detail, breaking them down to the tiniest parts. And what the scientists discovered blew away all our previous assumptions about Mars' habitability. Turns out, it's not just about Mars once being wet, but there was something that led to the gradual drying and cooling of the planet. In other words, Mars's water didn't just disappear. It evaporated quickly under extreme conditions. So, what happened to it? Astronomers produced two possible explanations. The first one says that Mars went through periods where it was sometimes wet and sometimes dry. The water didn't last a long time. It may have appeared in short bursts, with periods where it would dry up and then return. The second possibility is more intense. The water that was there was incredibly salty and cold, so instead of being liquid, it was mostly frozen in ice. This would have made the planet way too harsh for life as we know it, since the conditions would have been too extreme for anything to survive. Both possibilities sadly mean that Mars wasn't cozy and full of life in the past like some hoped. Well, at least not on the surface. That doesn't mean underground life couldn't exist though. This one is still a possibility. And to find more, we must keep looking for hints of water now. Actually, after years of exploring Mars, scientists have just made a mind-blowing discovery. Deep beneath the rocky surface of the red planet lies a hidden reservoir of liquid water. Real water this time, not the frozen ice caps or vapor in the atmosphere, though it's miles below the Martian crust. This breakthrough comes from data collected by NASA's InSight lander. This guy spent 4 years listening to the subtle tremors of Mars, Marsquakes, and it analyzed over 1,300 of them. Thanks to this, scientists were able to map out how seismic waves move through the planet, and it revealed pockets of liquid water buried 6 to 12 miles underground. Not just one lake, but puddles. So they used the same methods we here on Earth use to find underground water, oil, and gas, and they were able to piece together the Martian underground system. You see, as the water disappeared and dried out, some of it escaped into space when Mars lost its thick protective atmosphere. However, this discovery shows that much of the water didn't disappear. It just sank deep underground, where it still lies today. So close, but out of reach. That's a huge step forward. Water is the most important molecule when it comes to shaping the destiny of a planet. And also, even though we said that Mars wasn't filled with life before, this doesn't take away the possibility of it having life now. If liquid water still exists deep underground, could there be some little microbes hiding there as well? Life as we know it can't survive without liquid water. And now, with this, the idea of life on Mars has become more plausible than ever. There's a catch, though. While this water may seem like a jackpot to future Mars colonization plans, it's not going to be easy to reach. To say that drilling 6 miles deep into the crust is no small feat is an understatement. Just so you know, here on Earth, the deepest we've drilled is about 7.5 miles. It was in the Kola Super Deep Borehole project. And this project pushed current technology to its limits. Intense heat, pressure, equipment failures, you name it. With Mars, that would be even crazier. It has a much colder environment, extremely thin atmosphere, and lack of infrastructure. That would make any drilling mission extremely difficult. To reach water reservoirs buried so deep on Mars, we would need specialized drilling equipment that would somehow get delivered there. It should also be able to handle extreme cold, low pressure, and different gravity. Oh, and it should all operate remotely and preferably not break, all while it needs tons of energy. Yeah. Now, it's possible that we would only be able to do this in the future when we'll have automated systems or astronauts on Mars. That's not a quick task for even the most ambitious billionaires. So, for now, what these reservoirs hide is a mystery. But at least it's not the only one. As we mentioned, Mars hides one of the greatest secrets beneath its frozen southern pole, another buried vast lake of liquid water. The radar revealed it as it scanned the ice cap in this region. Hey, just don't make me pronounce it. Now, it's weird that it managed to stay liquid with such low temperatures. It's probably because of the geothermal heat beneath Mars' surface, and life could be there too. So now they're thinking about probing this lake first. That would be much easier. Curiosity's work is incredible, and it keeps helping us peel back the layers of Mars' ancient climate, giving us new pieces to the puzzle of what happened to our neighbor. And this could help us avoid similar mistakes in the future. Well, here you are. You're the first person to set foot on Mars. And your first mission is to explore a place called Jezero Crater. You're wading through the thick, rust-colored dust when suddenly you trip over something and almost fall. You lean closer to examine the culprit and recoil in horror. A skull is staring back at you. Who did it belong to? An ancient Martian dinosaur? A representative of a long-lost civilization? Now, this isn't a made-up story. That's what NASA's Mars robot called Perseverance would tell you if it could speak and, had consciousness. The rover had indeed found something strange, but it wasn't a real skull. It just looked like one. In reality, those were rocks that seemed to be out of place on the red planet. Right now, Perseverance is exploring the edge of a big, empty bowl-shaped area called Jezero Crater. Scientists think that a long time ago, this crater held a giant lake. Perhaps it was even full of tiny life. Since December 2024, the rover has been rolling down a steep hill called Witch Hazel Hill. It's an important mission because this hill might hold secrets about what Mars's weather and environment were like billions of years ago. Anyway, on April 11, 2025, Perseverance stopped to look at a special spot where two types of rock meet. One was light-colored and the other was dark. And right at that spot, scientists saw a weird-looking rock they later named Skull Hill. It stood out dramatically because it was dark and had a sharp shape. But the creepiest thing? It was full of little holes, a real nightmare for those with trypophobia. So NASA shared this discovery in a blog post. They explained that Skull Hill didn't look like the other rocks nearby. The area where Perseverance found these strange rocks is called Port Anson. Scientists think that many of the rocks there didn't originally form in that spot. They were moved from somewhere else an exceptionally long time ago. But how did they move, or what moved them? Now, don't get your hopes up. It doesn't mean we'll find space neighbors on Mars. These kinds of rocks are called floats. They are likely to have traveled a long way across Mars billions of years ago, back when the planet was much warmer and wetter, with rivers, lakes, and maybe even oceans. As the water dried up and the soft ground around the rocks slowly wore away over time, the tougher rocks stayed behind, sitting on the surface. Now scientists are trying to figure out how the strange holes on Skull Hill were made. One idea is that tiny parts of the rock broke off and wore away over time, leaving behind little pits. Another idea is that Martian winds, which carry dust and tiny rocks, might have slowly scraped the surface, kind of like sandpaper, and created the holes. Skull Hill is dark-colored, and at first, scientists thought it might be a meteorite that had come from space. But when they looked more closely at the chemicals in the rock using Perseverance's SuperCam, the results didn't match what you would expect from a typical meteorite.
Nope.
So, scientists now think Skull Hill might be a volcanic rock. On both Earth and Mars, dark volcanic rocks get their color from minerals like olivine, pyrozine, and biotite. If Skull Hill is volcanic, it might have come from old lava flows nearby that have broken down over time. Or maybe it was blasted out of the rock during a huge crash, something like an asteroid impact that dug deep into the ground and pulled up volcanic rock from below. What helps scientists in their research is that Perseverance now has some cool tricks that help it figure out what Martian rocks are made of. That's how we can learn where the rocks came from and how they formed. Lately, the rover has been super busy. In just a few months, it has collected samples from 5 rocks, studied 7 rocks very closely, and blasted 83 rocks with its laser to learn about them from a distance. That's the fastest pace of research since the rover landed on Mars 4 years ago. At least that's what NASA's Jet Propulsion Lab says. Usually, it can take months to find just one interesting rock in a crater. But up on the edge of the crater, aka the rim, cool and strange rocks are popping up all the time. Scientists are especially excited about getting these rock samples back to Earth to see if they'll show signs that life ever existed on Mars. But there's a problem. The plan to bring the samples back, called the Mars Sample Return Mission, is really complicated, expensive, and running into delays. So, for now, the samples are staying on Mars, waiting for their ride home. Hey, Uber! There's another rover that is currently working hard to help us get more information about our neighbor. That's Curiosity, and it might have found a clue about what happened to Mars's atmosphere from billions of years ago, thick and carbon dioxide rich. If the red planet once had warm temperatures and flowing water, what are the signs of all the carbon that should have been left behind? Now normally, a planet like that would have carbonates, minerals made when carbon dioxide reacts with water and rock buried in its soil. But on Mars, very few carbonates have ever been found, which has been a big mystery. Now, scientists might finally have an answer. A new study suggests that iron carbonate, called siderite, may be hidden inside Mars's sulfate-rich rock layers. These layers weren't easy to spot in satellite images from orbit. That might be the reason why carbonates may have gone unnoticed for so long. At one point in the past, Mars's carbon cycle got out of balance. The rocks started pulling in more carbon dioxide than they were releasing. Over time, this may have caused Mars to lose too much CO2 from its atmosphere. It cooled the planet and made it dry and lifeless. The planet might have been still habitable when this happened, but once carbon dioxide started turning into siderite, Mars may have begun getting too cold to support life. The Curiosity rover found these carbon-rich rocks in Gale Crater, an area on Mars that used to be full of water. The rocks also contain a lot of salts, which usually form when water dries up. This supports the idea that Mars went through some huge changes, likely from a planet with a nice climate to the cold, dry world we see today. If scientists find more siderite in other parts of Mars, it could help explain where all that ancient carbon dioxide went. Even better, it would support the idea that Mars was once warm, wet, and maybe even habitable. But that's not the only discovery Curiosity has made. The rover has a set of special instruments called SAM. Now, SAM's job is to study the rocks, dirt, and air on Mars to learn more about the planet. And one of SAM's biggest findings happened when it studied rocks from Gale Crater. SAM found organic molecules. Organic molecules are special because they're made of carbon, and on Earth, carbon is super important for life. Plants, animals, and people are all made from carbon-based molecules. So, finding these molecules on Mars makes scientists wonder if it's another proof that Mars once had life, a long, long time ago. When SAM looked even closer, it found certain patterns in gases like carbon dioxide and methane. These patterns might match what you would expect if tiny ancient life forms were making organic molecules. But there's also another explanation. These molecules might have been made by sunlight reacting with gases in Mars's air. In this case, no life would have been involved at all. On Mars, strong ultraviolet light from the sun can break apart and mix up molecules, creating new ones that eventually land on the ground. So even though scientists don't have a clear answer yet, finding organic molecules is a really big deal. At the very least, it tells us that Mars had the right ingredients for life, even if we don't know yet if life actually existed there. Now, scientists are using SAM and Curiosity's other tools to keep searching for more clues. The red parched earth under your feet is shaking. Large cracks are opening in the ground, threatening to swallow you. But unlike on Earth, these quakes aren't coming from within the planet. A threat coming from space is triggering them. Scientists have made a shocking discovery about Marsquakes. By using AI and NASA's InSight data, they found out that some of those tremors are caused by meteorite impacts. It means that Mars gets hit 2.5 times more often than we thought, and new craters are forming all the time. But the scariest part is that these impacts don't just shake the ground. They send powerful shockwaves deep into the planet, revealing a hidden seismic highway and an unstable interior, unlike anything we imagined. This changes everything we thought we knew about Mars. So now, the big question is, what else is lurking beneath the surface? But let's follow scientists' train of thought first. They took Marsquake data from NASA's InSight lander and compared it with fresh impact craters spotted by the Mars Reconnaissance Orbiter. That's when they discovered that some impacts create a seismic highway through the mantle instead of being absorbed by the crust. Even though NASA shut down InSight in 2022, its data is still precious. The lander, which placed a seismometer on Mars, recorded over 1,300 Marsquakes, some caused by underground rock cracking under heat and pressure, others, apparently, by meteoroids slamming into the surface of the red planet. By studying how seismic waves move through the crust, mantle, and core, scientists keep piecing together Mars's deep structure. In the past, researchers already linked impact craters with seismic data. But these new studies are the first time when a fresh impact has been connected to quakes detected in Cerberus Fossae. That's a highly active region 1,000 miles away from InSight. Scientists have discovered this 71-foot-wide crater much farther from NASA's InSight lander than expected, if we consider the strength of the seismic waves it produced. Mars's crust was thought to absorb most of the energy from impacts, which would limit how far seismic waves could travel. But the analysis of this crater revealed that, instead of getting dampened, the waves took a more direct and deeper path through the planet's mantle. This unexpected finding suggests that Mars has a seismic highway, which allows quakes to spread much farther than previously believed. Now, the InSight team will need to reassess their models of Mars' internal composition and structure. And then, we might better understand how impact-generated seismic signals can reach such depths. Manually sorting through the vast amount of data would have taken years. But luckily, these days, there are new tools, and scientists can go from tens of thousands of images to just a few in a matter of days. So, researchers focused on finding craters within approximately 1,800 miles of InSight's location. Their aim was to identify those that formed while the lander's seismometer was active. By comparing before and after images from the context camera over time, they identified 123 fresh craters to cross-reference with InSight seismic data. Out of those, 49 craters were potential matches for quakes detected by InSight seismometer. And after conducting some more analysis, the team decided that the 71-foot Cerberus fossae impact crater was the main finding. This discovery is likely to help scientists differentiate between signals from internal quakes and those caused by meteoroid impacts. Initially, they believed that Cerberus fossae produced a lot of high-frequency seismic signals linked to quakes originating inside Mars. But the new data suggests that some of this activity may have been caused by impacts, not internal processes. Another mystery scientists haven't been able to crack for 50 years is why Mars is split into two very different halves. But thanks to recordings of Marsquakes, they may have finally found the answer. Since the 1970s, researchers have known that Mars has two distinct regions. The northern lowlands cover about two-thirds of the planet's northern hemisphere, and the southern highlands make up the rest. The southern highlands sit about 3 miles higher than the northern lowlands, and the crust, the planet's outer layer, like a shell, is thicker in the south. This strange divide is known as the Martian dichotomy. There are two potential explanations for this imbalance. One theory suggests that an unknown internal process within Mars created the difference. The other claims that a massive collision, probably with a moon-sized space rock or several smaller impacts, once reshaped the planet's surface. But Mars' surface is extremely old. That's why pinpointing exactly what happened has been difficult. But now, a new study, published on December 27, 2024, has used Marsquake data from NASA's InSight lander to figure out whether the cause of this difference lies deep inside the planet. InSight was positioned near the boundary between the northern lowlands and southern highlands. Its mission included recording seismic data from Marsquakes, which travel through the planet's mantle, the rock layer beneath the crust. So scientists compared how these waves moved under both lowlands and highlands. They looked for differences in the planet's deep interior. It turns out that the seismic waves lost energy much faster when traveling through the southern highlands. It means that the mantle beneath this region is significantly hotter than in the north. It's compelling evidence that internal planetary forces, rather than an external impact, caused Mars' unusual split. The research team believes that the temperature difference between Mars' two halves can be traced back to ancient tectonic activity. It once shaped the planet, but later stopped. At some point in the past, Mars had moving tectonic plates, like Earth's. As these plates shifted, they, along with the molten rock beneath them, could have created the Martian dichotomy. But eventually, the movement stopped, leaving behind what scientists call a stagnant lid. That's a thick, immobile layer over the planet's molten interior. If this turns out to be true, it might mean that the mantle beneath the southern highlands is still pushing upward, while the mantle under the northern lowlands is sinking deeper toward the planet's core. This ongoing process could explain why Mars' crust is thicker in the south. At the same time, we can't completely rule out the idea that an external impact created the dichotomy. Some recent studies suggest that a giant collision could still be a possible explanation. To solve this mystery for good, scientists will need more Marsquake data and detailed models of how Mars originally formed. By the way, if you ever decide to visit Mars, you might come across the hero of our video today, the InSight lander itself. It was supposed to launch in March 2016, but a problem with one of its instruments caused a delay. It was a vacuum leak in the seismometer. NASA rescheduled the launch for May 2018, and the issue was fixed in the meantime. But this delay increased the total cost from $675 million to $830 million. Still, InSight successfully landed on Mars on November 26, 2018. But over time, dust built up on its solar panels, making it harder to recharge. The InSight lander runs on solar panels and batteries, but it needs occasional wind gusts, called cleaning events, to clear dust from the panels. Unfortunately, the place where InSight landed didn't get enough of these winds to keep the lander fully powered. By February 2021, during the Martian winter, thick dust had covered the panels, and they were only producing 27% of their full capacity. To save power, NASA started putting InSight into hibernation mode, shutting down instruments gradually to keep its electronics warm. They hoped better weather would allow the lander to recharge and wake up by July 2021. In May 2021, the team found a clever way to restore some power by using the lander's arm to move sand onto the panels, helping the wind clean off some of the dust. But eventually, InSight was only generating 1/10 of the power from the sunlight than it did right upon arrival. In July 2022, NASA put it in low power mode to keep detecting Marsquakes. The lander kept operating until December 2022. On December 20th, NASA announced that InSight had lost contact with Earth on December 15th, and the mission officially ended on December 21st, 2022.
If you're scared of spiders, never ever visit Mars. In March 2025, NASA's Perseverance rover found something looking like a bunch of tiny spider eggs on the surface of the red planet. This something is made up of hundreds of little round balls stuck together. What if all these eggs hatch? Will hordes of 8-legged creatures swarm the red planet? Doubtful. The thing found by Perseverance was just sitting there on a hill called Witch Hazel, near the edge of Jezero crater. On closer inspection, it turned out to be a weirdly shaped rock with a bit of Martian dust on it. Yeah, sadly, or luckily, those weren't Martian spider eggs. Even so, the formation really stood out from everything else around it. The Perseverance team named the weird rock St. Paul's Bay. It's what scientists call a float rock. This term means that it didn't form where it was found, but somehow got moved there. So, at the moment, we don't have enough clues to figure out its background and how it got that strange texture. But that's not the only mystery. Something had to move this rock from its original spot. One theory claims that the rock could have been created when a meteorite smashed into Mars. The powerful impact must have blasted rocks into the air, and those bits could have cooled down and formed the tiny balls we see now. If that's true, this rock might have come from really far away, and it could give us new info on how big impacts move stuff around on the red planet. NASA thinks the rock might have just rolled down Witch Hazel Hill. It could have come from one of the darker layers up on the hill. We have seen those layers from space. Now, the goal is to study Witch Hazel Hill more closely and find out if those layers are made of the same stuff as the St. Paul's Bay rock. If so, it might mean a few things. Maybe there was volcanic activity in that region, or a big meteor hit, or there might have been groundwater there in the past. If this theory turns out to be true, there's a chance that some of those rocks might hold tiny fossils from ancient microbes. That's why NASA is planning to bring some of the rocks back to Earth in the 2030s with the Mars Sample Return mission. We'll get to study them up close and maybe, just maybe, find signs of ancient Martian life. Now, the funniest thing about it all is that it isn't the first time scientists have dealt with arachnids on Mars. Spiders on Mars is actually the nickname for a weird-looking surface feature. In certain places on Mars, you can see big dark cracks that spread out like spider legs. Some are huge, over 3,000 feet wide. From above, they seriously look like a bunch of creepy crawlers moving across the planet. These spooky shapes were first spotted by Mars orbiters in 2003, and they've been showing up in satellite photos ever since. At first, no one had a clue what they were, but now, scientists think they form when carbon dioxide ice, dry ice, sitting on the surface, suddenly turns straight into gas. That fast change causes gas to shoot through the ice and carve out all those strange crackly patterns. An even cooler thing is that NASA scientists have been able to recreate those Mars spiders in the lab here on Earth. They built a special setup mimicking Mars's surface and watched tiny versions of the spiders form right in front of their eyes. The team had been trying to recreate those Mars spiders for 5 years. When it finally happened, they were overjoyed. Back in 2021, scientists managed to explain how those spider-like marks form on Mars using something called the Kiefer model. The basic idea is that in spring, sunlight shines through big, clear chunks of frozen carbon dioxide, aka dry ice. That heats the Martian ground underneath, and the ice starts turning straight into gas. The gas builds up under the ice, and when the pressure gets too intense, boom, the ice cracks. Gas shoots out, dragging dark sand and dust with it, leaving behind those spooky spider patterns once the ice melts in summer. The team tested this theory using a big special chamber nicknamed Dusty. Yeah, that's a real name. It's about the size of a barrel and can recreate the freezing cold, super low pressure conditions on Mars. We're talking about -301 degrees Fahrenheit. The researchers also put fake Martian soil in the chamber and covered it with CO2 ice. Then they used a lamp underneath the soil to heat it up, just like the sun heats up Mars. Their experiments worked, and little spider shapes formed just like they do on the red planet. The study also revealed something new. The team found that ice formed inside the ground too, and it caused the soil to crack along with the ice. This might explain why the spider's legs are so zigzagged instead of straight, like we might expect. Next, they want to keep doing experiments to figure out more about the Martian spiders, like why they only show up in some places on Mars and why they aren't getting more common over time. The red planet is apparently set on playing tricks on people from Earth. For example, in April 2023, NASA's Curiosity rover took a little break from searching for signs of ancient water on Mars and stumbled upon something curious: a travel book. Later, scientists realized that it wasn't really a book, just a rock. But it does look like a little hardcover with a page frozen mid-turn. This book rock is tiny, measuring only about 1 inch wide. So it might not hold any ancient Martian stories, but at least it's travel size. Then in January 2023, the University of Arizona shared another bizarre image. A rock formation that looked like the face of a giant teddy bear. It had 2 distinct beady eyes, a button nose, and an upturned mouth. It was captured by NASA's Mars Reconnaissance Orbiter, which was orbiting the red planet at the time. Scientists from the University of Arizona explained that the teddy bear face was likely just a natural formation, like a broken up hill or mound in the center of an ancient crater. Another cool find occurred in February 2022. The Curiosity rover spotted something that could only be described as a tiny flower made of minerals. It looks like little coral branches, but it's actually a mineral deposit, which is pretty rare to see in a flower-like shape. Most of these kinds of deposits are formed when ancient water mixes with rocks on the Martian surface, so they're not exactly new to scientists. But this one is unique, since it looks like a tiny plant or flower. Now, the next discovery is even wilder. Once, the Curiosity rover snapped a pic of what looked like a perfect doorway in a Martian cliff. Naturally, people started wondering if it was some kind of secret entrance or maybe a hidden base for astronauts. But in reality, it's just a really cool rock formation. Winds and erosion carved away at the rock over time, creating a perfect symmetrical shape. Going even deeper into the past, back in 2018, a researcher noticed weird stick-like shapes in an image and thought they looked like fossilized animal footprints. Unfortunately, NASA quickly shot down the idea. Those tracks turned out to be salt deposits that formed in areas where water evaporated. You can find something similar on Earth too, for example, in dry lake beds. So, while it's pretty interesting that there's more proof that Mars used to have rivers and lakes, these tracks aren't evidence of life, just a quirky rock formation. Now, the next find is absolutely amazing. NASA's Opportunity rover found round, blueberry-like rocks on Mars back in 2004. But those aren't the kind you eat with your cereal. The blueberries you're looking at are made of iron, and they're evidence that Mars used to have a lot of water. Over billions of years, water smoothed them out and created these little balls. Scientists think that they formed when Mars was much wetter than it is now. The iron-rich blueberries are a pretty big deal because they show that Mars could have been a very different place a long time ago.
And we have liftoff off of Mars Global Surveyor as America begins its journey back to the red planet.
There's a weird structure on Mars, a square, a near-perfect square standing alone in the endless red desert. And it looks too perfect, too precise to be anything but artificial. Nature's chaotic, and it rarely makes things look so deliberate. So the internet took one look at it and lost its mind, as the internet tends to do. The image spread like a virus on social media, igniting every conspiracy theory you can think of. Some were convinced it was proof that intelligent life had once tread upon the Martian sands. Well, let's dive in and sort it out. The image is real, and it's really old. The thing, not the picture. NASA's Mars Orbiter camera snapped it in 2001, capturing a tiny slice of Martian terrain, and there sat the square. Now, is that evidence for intelligent life? Well, Mars is an empty world now, a rust-colored desert. But once, long ago, it may have been something else entirely. A planet filled with roaring rivers, vast oceans, and thick clouds rolling across the sky. Now, in a world like that, life, if it ever had a chance, could have taken root. And there's a possibility it did. Scientists think that life could have existed on Mars in a short period from around 4.1 to 3 billion years ago. It could have started during the early era of Martian history, called the Noachian period, and lasted all the way to the late Hesperian period. Meanwhile, here on Earth, the first oceans were just forming. Life on our planet was just beginning, in the form of tiny bacteria in deep-sea hydrothermal vents. While Mars was already fully wet, on Earth, there were no plants or animals, just microscopic life trying to survive. So, Mars took the lead in the life game. It had a much thicker atmosphere, which could have trapped enough heat to keep water liquid. Valley networks, huge traces across the red landscape, show us the incredible story of rainfall, rivers, and lakes. Huge asteroids were still hitting Mars at the time, and they could have brought organic molecules with them. But if that's true, what happened and where did life go? A recent NASA study suggests that the answer is more complicated than we thought. Astronomers believe that something drastic happened to Mars, like boom, and its cozy climate was gone, its atmosphere thinned. Without a strong magnetic field like Earth's to protect it, solar radiation stripped away the air, leaving Mars cold and dry. The ocean simply evaporated. Some of the water escaped into space while the rest froze underground or became locked in polar ice caps. Today, all that remains is a ghostly memory, dry channels and salty mineral deposits. But it looks like the transition wasn't sudden at all. It was slow and gradual. The planet was changing from wet and warm to cold and dry over millions of years. In fact, Mars kept its ocean even after the temperatures dropped to freezing. Some parts of Mars, especially the northern lowlands, might have remained wet for many, many centuries. Shouldn't the water freeze when it gets below 32 degrees Fahrenheit? Well, yeah. But there are many reasons why this miracle happened, like Mars's thick atmosphere and warm water traveling through currents. And during that time we mentioned before, from Noachian to the late Hesperian, life could have found a way. Microbes on Earth thrive in some of the harshest places, beneath Antarctic ice, in deep sea vents, in toxic volcanic lakes. Hey, life doesn't care. So these times in Martian history would be amazing for it. But don't be mistaken, Mars was never a paradise. Even during its cozy times, it wasn't as lush and green as we might imagine. In its early days, Mars was something more extreme, something closer to the young Earth. During the Noachian period, it was warm yet wet. Then, the climate shifted into the Hesperian period. Oceans were stretching across the northern lowlands. Temperatures dropped, and snow piled high, forming massive glaciers in the south, transforming the planet into an icy world. Finding microscopic life at that time is possible, but an intelligent civilization? That's less likely. The square that went viral isn't evidence for intelligent life yet, and here's why. First things first, people freak out because nature doesn't make straight lines. But that's not really true. Actually, nature does it all the time. For example, here on Earth, we have the Giant's Causeway in Northern Ireland, a beautiful field of hexagonal basalt columns. These are completely natural. They're formed by volcanic activity. There's also the Devil's Tower in Wyoming. Hey, remember it from the Close Encounters movie in the 80s? That's a symmetrical rock formation, and it was created by erosion. However, if we looked at these things from space, they'd look artificial. So, what is the square? How about a fracture pattern in the rock or some terrain that's broken apart along straight lines due to stress? This happens on Earth all the time when rock expands and contracts over time. And on Mars, the surface is just constantly battered by meteors, winds, and extreme temperature shifts. No wonder rock would get stressed. What happens here is another case of pareidolia. It's our brain's favorite thing, to spot patterns in something random. Hey, we evolved like this. So sometimes we might look at natural objects and see insane stuff. Faces on trees, animals in clouds, shapes, and so on. Besides, NASA has been photographing Mars for decades. We have high-resolution images of craters, mountains, valleys, riverbeds, everything. Wouldn't an ancient civilization leave us, well, something better than some square-like rock? Even though things erode over time, we'd find more signs, roads, foundations, artifacts, ruins, or at least something. Though, to be fair, we do see something. The square wouldn't be the first time Mars has played tricks on us. Over the years, we've spotted everything, from tunnels to carved faces, even Bigfoot. Or this doorway, for example, a perfectly cut rectangular opening. That's what people saw when NASA's Curiosity rover sent back an image of the East Cliffs on Mount Sharp. It's almost like an ancient passage leading deep into the surface. You just need to go in and find some fantastic underground base. Well, NASA decided to take a closer look at it. It turns out it's just 12 inches tall and 16 inches wide, the size of a dog door. That's because what we're looking at isn't a doorway, but an open fracture, a break in the rock that happens naturally over time. These kinds of cracks are extremely common, both on Earth and on Mars. They form when bedrock is stressed, expands, contracts, or gets eroded by wind and time. If you walk through a desert here on Earth, you'd see plenty of similar shapes. Canyons, cliffs, and even boulders have fractures that, from the right angle, might look like doorways. They're just not getting photographed by NASA. Also, the straightness of lines turns out to be just a trick of perspective. If you zoom out, you'll see that it's just one small break in a much bigger rock formation. Or the infamous Cydonia face. The photo was taken back in 1976 by NASA's Viking 1 orbiter when it was scanning Mars. In the region known as Cydonia, it captured what looked like a massive humanoid face, a rocky formation about 1.2 miles long. And this one face inspired books, documentaries, movies, and podcasts. But when NASA's Viking orbiters first took pictures of Cydonia, the cameras weren't super advanced. The image of the face had a low resolution and made the details fuzzy. NASA's later missions had far better cameras, and when Mars Global Surveyor revisited Cydonia in 2001, the truth was undeniable. The face was just a hill, a lumpy rock formation with ridges and depressions carved by wind and erosion. And in 2006, during another mission, a colored image with insanely high detail was made. No traces of face left there whatsoever. That's another pareidolia trick for you. Now, Mars has plenty of secrets left to uncover, but they will be related to its fascinating history, not some secret ancient civilization. The conclusion is, don't trust everything you see online. Sometimes a mysterious rock is just a rock. It looks like a regular beach, but something sets off an alarm blaring in your head. The sand looks too red. The sun is too bright. The wind is all wrong. It's hard to breathe. And there's no water in the ocean. Well, panic not. It's normal, since you're on Mars. For the longest time, we've seen Mars as a dry, lifeless dust ball, a freezing desert where water exists only as ice or vapor. But new research suggests that billions of years ago, it was a totally different place. And instead of endless dust, it may have had something much more familiar to us: sunny, sandy beaches. Scientists from Penn State, UC Berkeley, and Guangzhou University studied radar data from China's Zhurong rover. It started to roll across Mars in 2021. While exploring the surface of the red planet, it found sloping rock formations that looked strikingly similar to the ones found on Earth's coastlines. Those are called foreshore deposits. They form when waves push sand onto a shoreline. But Zhurong wasn't just taking pretty pictures. It also had ground-penetrating radar, a tool that allowed it to scan deep below the Martian surface as it traveled 1.2 miles between May 2021 and May 2022. And it found something pretty wild: layers of sediment sloping down at a 15-degree angle. This pattern is identical to the ones left behind by waves on Earth. And this wasn't from the wind, volcanoes, or anything else. It just looked like a real beach. And that's actually a big deal. Because if there were waves and tides, there must have been a large body of water. That means Mars may have once had just the right conditions for hosting life. Even after 3.5 billion years, the formations are still incredibly similar to beaches on Earth. So there must have been a time when Mars was much more than just a dusty rock in space. After revealing this shocking news, Zhurong's radar scanned 260 feet deep into the ground, discovering sediment layers. They once formed along a path perpendicular to an ancient shoreline, the one that likely existed 4 billion years ago. At the same time, it might not be all that surprising. Back then, Mars wasn't the dry, frozen wasteland we see today. It had a thicker atmosphere, a warmer climate, and plenty of liquid water. And I'm not even talking about some tiny puddle. Beaches don't form without a massive body of water. For waves to shape the land like this, there had to be rivers flowing into a vast ocean. Powerful currents had to be moving sand around, and water had to stick around for a long time. This couldn't be just a brief wet spell. It was a period where Mars was hydrologically active for millions of years, potentially being a place where life could have thrived. This discovery gives even more weight to one theory. It has been puzzling scientists since the 1970s. That's when NASA's Viking spacecraft snapped images of what looked like a shoreline wrapping around Mars's northern hemisphere. But there was a problem. The shoreline was all over the place, with elevations varying by up to 6 miles. Wow, which is nothing like our flat, mostly consistent shorelines we see on Earth. This difference made scientists doubt that a Martian ocean ever existed. For years, scientists have been trying to crack this mystery. In 2007, they suggested that Mars' rotation actually shifted billions of years ago. As the planet's massive Tharsis volcanic region grew, the planet's spin axis tilted, warping the surface. It could explain why the shoreline is so uneven today. In other words, what once was a flat and level landscape got distorted over time. Interestingly, Mars has been dropping hints about its watery past for years. Curiosity found ancient ripples in Gale Crater. There were signs of a long-gone lake. Perseverance is currently studying a fossilized river delta in Jezero Crater. Now, with Zhurong's evidence of an ancient ocean, it all comes together. Small lakes? Check. Rivers? Check. A massive ocean covering the northern lowlands? Quite possibly. Zhurong's mission wrapped up in May 2022 after dust blocked its solar panels, but future missions could still explore those ancient shoreline deposits. Scientists might send new missions to drill deeper into the ground to retrieve samples. Or we could use better radar to map Mars' subsurface in more detail. There's a real hope to excavate those areas in the future and find even more clues about Mars' past. At the same time, NASA's Perseverance rover is already working hard in Jezero Crater collecting samples. Scientists hope that it will bring them back to Earth in the 2030s. While those won't include samples from the ancient ocean, they could still help us find out more about Mars's wetter history. For now, the discovery of ancient beaches on Mars gives us a peek into a time when the planet might have looked a lot more like Earth, with water, waves, and rivers. Now let's speak about the Perseverance rover that's still working on Mars in more detail. It has a special drill on its arm and uses it to scrape off the dust and top layers of rock, making small 2-inch wide circles in Jezero Crater. Once, one of its cameras took a close-up photo, and the image showed that the rock wasn't smooth. It was made of tiny interlocking crystals. The rover used 2 special tools to analyze the rock's chemistry. The results confirmed that the rock, named Rochette, was volcanic. It meant it formed from lava or magma, not from mud and clay, like scientists had expected from a former lakebed. Perseverance, also known as Percy, landed on Mars in February 2021, along with a small helicopter named Ingenuity. It is the most advanced rover ever sent to Mars, following in the footsteps of Curiosity, Spirit, Opportunity, and others. But Percy has a different mission. While older rovers mainly studied Martian rocks and climate, Perseverance is searching for signs of past life. Scientists chose Jezero Crater because it looks like it used to be a lake where tiny life forms could have lived. The rover drills, scrapes, and collects rock samples to study with its science tools. It also saves some samples to bring back to Earth in the future for even closer study. Perseverance has found some surprising things on Mars. Scientists studying the data it sent back have discovered that Jezero Crater has changed a lot over time. Long ago, this area had flowing lava, a lake that lasted for thousands of years, rivers that carried mud and sand, and even massive floods that brought in rocks from far away. It means that Jezero's history is more active and unpredictable than scientists expected. This definitely made it harder to find the sedimentary rocks they were looking for. But it has also revealed new places where ancient life might have existed. Another exciting discovery is that every rock Perseverance has studied so far contains carbon-based materials, the same stuff that life on Earth is built from. NASA's Perseverance rover also carries a special tool called MOXIE, which has managed to make oxygen from the carbon dioxide in Mars' atmosphere for the first time. Over 16 test runs, MOXIE produced about 4 ounces of oxygen. That's enough to keep an astronaut breathing for about 4 hours. It worked even better than expected, making up to 0.42 ounces of oxygen per hour. After running successfully for 2 years, MOXIE completed its final test in September 2023. It brings us one step closer to sending humans to Mars in the future. In any case, back to the discovery of ancient shorelines on Mars. This finding might help us see the red planet with new eyes. Water might have been flowing across its surface for tens of millions of years, carving out lakes, rivers, and even a vast ocean. What else have we misunderstood? Did Martian dinos stroll across the vast green valleys of the planet? Or were those bizarre marine creatures the likes of which we can't even imagine? Well, we don't know yet, but one thing is very likely. Mars had an era of warmth, water, and maybe life. Recently, scientists have made an astounding discovery that can change the entire course of Mars exploration. Apparently, there are oceans of liquid water on the red planet, so the future looks bright. We could use this water to support future missions, and then even relocate to Mars since we wouldn't need to worry about where to get this precious liquid, right? Well, there's one big problem. These oceans of liquid water are in Mars, so deep inside that we aren't likely to get there. At least that's what a new analysis of seismic data collected by the Mars Insight lander claims. Huge reserves of liquid water seem to be the best explanation for some seismic quirks of the red planet. So all this precious water is out of our reach. But we need to find it to solve the puzzle of the aquatic history of our blushing, dusty neighbor. And the first thing we need to do is identify where the water is and how much of it the planet is hiding.
Navigation has confirmed that the parachute has deployed and we are seeing significant deceleration.
Now, our rovers are scurrying about on the surface of the red planet, gathering all the available data on the planet's surface geology. And it's getting increasingly obvious that Mars was once covered with water. Many factors, from Martian terrains to ancient dry lake beds and deltas, suggest that there was a time when the planet was quite soppy. These days, there's still some water on and right below the surface of Mars, but it's in the form of ice and nowhere near what Mars had in the ancient past. To understand how much of it could have been on the red planet billions of years ago, we must know where all this water went. There are two spots where the water could have gone: into space or toward the interior of Mars. Then it could have been isolated as either liquid reservoirs or ice deposits. Currently, we don't have any way of measuring how much water once leaked away. But now, we finally can find out more about the gooey center of the red planet. All thanks to the Mars Insight lander. It isn't operating anymore, but from November 2018 to December 2022, it was listening to the hums and rumbles and monitoring the activity below its feet. The thing is, acoustic waves generated by seismic activity deep inside the planet can change according to the composition and density of the material these waves are moving through. And scientists can get a lot of information analyzing the behavior of seismic waves. In this case, they used a model similar to those used to map underground oil fields and aquifers on our home planet. Then, with the help of this model, they analyzed the data gathered by InSight on Mars. They discovered that the best explanation could be that there was a layer of fractured rocks whose cracks were filled with water deep under the surface of the red planet. That layer could be at a depth of 7 to 12 miles. That's why it would be extremely tricky for future missions to get to it. And still, the new discovery could help us understand the Martian water cycle. Confirming the existence of a large reservoir of liquid water can help us sneak a peek at what the climate on Mars used to be or what it could be like one day. And if once Mars had a lot of water, it could have been habitable in the ancient past and might become habitable in the future. Water is crucial for life as we know it, so underground water reservoirs on the red planet could already be habitable. Maybe, while we're talking, tiny microorganisms or even some tentacled creatures are living their lives in the comfort of their underground home. On Earth, super deep mines do host life, and the bottom of the ocean, with its immense unbelievable pressures, isn't lifeless either. So far, we haven't found any evidence of life on Mars, but for now, it sounds like this place has the potential to sustain life. InSight data has shown that there isn't likely to be a lot of water ice in the upper crust of the planet, at least in the region around the lander. But if it turns out that there is a water-rich layer deep below the surface and stretching around the entire globe of the planet, then there would be enough water to fill ancient ocean beds and even more. Now, Mars isn't the only place outside Earth where there is water or where we might one day find water. Take the good old Moon, for example. On Earth's natural satellite, water can be found all over the surface, but it's not the water you might be imagining. On the Moon, water remains mostly as ice, and it's distributed unevenly. For example, the poles of the Moon are the regions that never receive sunlight. This is the reason they're extremely cold, And it's no wonder there's a lot of ice there. The ice in these areas is often mixed with the lunar soil and hiding deep below the surface. Then there's Enceladus, the sixth largest moon of Saturn. In reality, it's not that large, just 314 miles across. In other words, this moon is small enough to fit inside Arizona. Ooh, we should try that. Well, interestingly, when the Cassini space probe first arrived at Saturn, researchers were expecting Enceladus to be a frozen ball of ice. But what they saw was plumes of icy particles and water vapor erupting from geysers on the moon's surface. It was clear that there was a massive ocean between the moon's rocky core and its icy shell. Then there's Jupiter's moon Europa. Scientists think that this world is one of the most promising places in the solar system when it comes to searching for new life forms. That's because Europa has a huge saltwater ocean as deep as 40 to 100 miles. And even though it's under a layer of ice that is likely to be 10 to 20 miles thick, it's still potentially habitable. Astronomers believe that plumes of water might erupt from cracks in the ice shell and release the contents of the moon's ocean into space. The temperature, pressure, and chemistry are very different on Europa, and astronomers aren't sure yet how the ice behaves there. That's the main reason they haven't figured out yet how deep or large the water reservoirs on Europa are and how long they need to refreeze. But out of all the places where we could find water in the universe, the most bizarre is probably open space. In 2011, two teams of astronomers discovered a cloud of water floating freely among stars. It was the largest and farthest reservoir of water ever detected. So this massive cloud of water vapor surrounds a black hole. But not just any black hole. This one's a quasar, located 12 billion light-years from Earth. The conditions around this quasar must be really special to create such an enormous amount of water. This cloud contains 140 trillion times the volume of all the water on Earth. That's enough to give every person on the planet a whole planet's worth of water 20,000 times over. Sounds wild, doesn't it? But there's something even cooler. Astronomers think this water cloud formed just 1.6 billion years after the universe began. This discovery is yet another sign that water has been around all over the universe, even in its early days. But here's the kicker. Until they found this, scientists had never detected water vapor so far back in time. Sure, there's water in our Milky Way galaxy, but most of it's frozen solid in ice. This discovery really pushes the boundaries of what we know about water in the universe.
There are tons of weird things on Mars. Spoons, noodles, doors, even faces. Are they all really just rocks? Besides, it's not the only planet in our solar system full of mysterious things. Let's check them out. Recently, we found a strange thing on Mars that looks like a smooth, spoon-like object. It grabbed everyone's attention after NASA's Curiosity rover spotted it. The rock, with a handle and rounded tip, looks like it's floating in the rover's photo. People on the internet are puzzled about what it might be. Some are joking that it's a Martian's bowling pin, or even a shoehorn left by extraterrestrial creatures. But Andrew Good from NASA says it's not that exciting. Turns out it's just a rock shaped by the wind over a long time. These kinds of rocks with odd shapes are common on Mars. They're called ventifacts. Ventifact is a rock that can get scratched, dented, or smoothed out by tiny particles carried by the wind. You'll usually find these kinds of rocks in dry places where there's not much grass or trees to block the wind, and where there's a lot of sand blowing around. Sometimes, the wind can carve ventifacts into really cool shapes, like the mushroom rocks you can see in the White Desert National Park in Egypt. These rocks look like giant mushrooms because the wind wears away the bottom part faster than the top, making them stand tall and slim. Ventifacts aren't the only cool Martian rocks. Check out this series of surreal spikes protruding from the red surface. NASA's Curiosity rover stumbled upon them while exploring the Gale crater on Mars. They quickly caught everyone's attention. Twisting structures resembling spikes looked like some extraterrestrial doors. Even the SETI Institute, an organization focused on searching for extraterrestrial life, tweeted about the image, referring to it as a cool rock. But in reality, these are just hoodoos. These tall and thin spires occur when hard rock sits atop softer rock layers. Martian spikes are likely cemented fillings of ancient fractures in sedimentary rock, with softer material eroded away over time. Again, there are many hoodoos on Earth too. They're also called fairy chimneys or tent rocks. You can find them in places like Utah's Bryce Canyon and the Colorado Plateau. NASA is excited about these weird structures because they can help us learn more about the history of the Gale crater. There was also a rock that looked like a jelly donut. We called this rock Pinnacle Island. It was spotted by NASA's cameras. However, just 4 days earlier, it was nowhere to be seen. So how did it magically disappear? In a very anticlimactic way, it was kicked up by one of Opportunity's wheels as it traversed the Martian terrain. But there's still some mystery surrounding that jelly donut. Analysis revealed that Pinnacle Island contains unusually high levels of sulfur and manganese. Both of these things are water-soluble. In other words, there might have been some water action that created these elements in the rock. So this tiny thing suddenly caused a lot of drama, and an entire lawsuit against NASA. It claimed that the agency failed to investigate a possible fungus growing on Mars. Jelly donut fungus. But not all our findings are natural. Another puzzling discovery was this thing the Perseverance rover spotted. It's something that looks like tangled spaghetti or string. Just like the donut, this mysterious object showed up in a rover camera image and then vanished from the sandy ground in several days. It turns out that it could be debris from the rover's landing system. Perseverance landed in the Jezero crater in February 2021. It had a rough landing and accidentally scattered debris around. Some of these debris pieces have been showing up in the rover's images for a while now. The string-like object is likely a piece of shredded Dacron netting, which is a type of fiber used in thermal blankets. These blankets help regulate equipment temperatures during the super hot process of landing on Mars. It probably underwent significant unraveling and shredding due to strong forces during the landing. Thermal blankets lost a bunch of stuff back then. For example, this shiny foil piece spotted in June. The rover found it on a rock. What's remarkable is how far some of the debris has traveled. The rover landed about 1.2 miles away from where it's currently exploring. It's probably because the crash threw the debris into the air, and the Martian winds carried it over such a distance. Mars is known for its strong winds, which can move lightweight objects. However, while it's fun to stumble upon them on images, there are concerns about the debris and trash on Mars. We haven't even fixed this problem on Earth, and we're already creating it on Mars. The debris we left on the red planet is already accumulating in an area called Hogwallow Flats. Plus, the debris can accidentally contaminate the sample tubes used for collecting Martian rocks. So far, NASA isn't overly worried about this, but they're keeping a close eye on it to prevent any issues with the rovers. Now, how about not things, but animals? Curiosity caused quite a stir when it captured something that looked like a rat on Mars. Some started speculating that it could be evidence of indigenous Martian life, or even that this rodent was brought along by Curiosity. But the Mars rat, once again, turned out to be just a weird rock. It looked interesting because of the natural processes like wind erosion and mechanical abrasion. We also found some worm-looking things. Curiosity snapped a picture of a formation that looks like worms wriggling across the Martian landscape. Despite its tiny size, this formation stands out with its unique shape and rough texture. It's probably made of durable material resistant to Mars's harsh erosion. And finally, our top mysterious finding is the face on Mars. Cydonia is a region on Mars that has captured both scientific and popular interest. It's located in Mars's northern hemisphere. It lies between heavily cratered regions to the south and relatively smooth plains to the north. There's a theory that the northern plains may have once been ocean beds. Maybe Cydonia was once a coastal zone. This place is full of interesting and beautiful features that tell us a lot about the history of the Red Planet. But its most interesting feature was the Martian face. This thing gained widespread attention when it was snapped by the Viking 1 orbiter in 1976. Some believed that it was evidence of a long-lost Martian civilization. At first, NASA dismissed it as a trick of light and shadow. But after some analysis, it turned out to be, yep, another rock. We also saw a face of a bear. It was captured by the high-resolution imaging experiment camera. In an image, we can see a circular fracture pattern that looks like a bear's head, with two craters forming the eyes and a V-shaped collapse structure like the nose. The head likely formed because something heavy settled on top of an old hole in the ground. This hole was filled with either lava or mud. The nose-like feature is speculated to be a volcanic or mud vent. But why do we keep seeing these strange things on Mars? Sometimes our brains can trick us into seeing things like faces or objects in rocks and other things. But these are just illusions called pareidolia. Pareidolia is a psychological phenomenon that makes us see familiar patterns or shapes, especially faces, where none actually exist. It's because the brain encounters something it doesn't recognize or understand right away. It tries to find things that look the most like this one. So it sees random patterns, textures, or sounds as something meaningful and recognizable. That's why a chair and clothes on it seems like a super creepy human-like figure at night. It also causes you to see faces or shapes in clouds, or hear recognizable sounds and even words in random noise. It's a fascinating proof of the power of our perception, but we also should be careful with it and not let our imagination run wild.
Imagine something terrible happening to Earth and humans having to leave it as fast as possible, and you have to decide which planet will become your new home. Which one will you pick? Probably the first planet that comes to mind is Mars. It's relatively close. Like Earth, it's also a rocky planet. It even has an atmosphere, even though it's much thinner than what we have on our planet. But at the same time, the North Pole on Earth would seem balmy to you in comparison to Mars. On the red planet, the average temperature is minus 80 degrees Fahrenheit. The most radioactive areas on our home planet might seem harmless if you compare them with the surface of Mars. But what if we terraform Mars? Could we keep transforming the red planet until it becomes capable of supporting human life? It would be an enormous feat. Mars is an extremely dangerous place. Should you teleport there right now, without any protective suit or anything, the gas in your blood would instantly turn into bubbles. You can probably imagine the consequences. Add oxygen deprivation, cold exposure, and radiation poisoning to the equation, and well, who's next? If we still decided to terraform Mars, we would need to create a stronger magnetosphere. We've got this protective magnetic layer on Earth. It shields us from the sun's ultraviolet radiation. The red planet would also need a thicker atmosphere, again for protecting us from harmful space stuff better. Right now, the Martian atmosphere is almost entirely composed of carbon dioxide with tiny amounts of oxygen. For us to live there comfortably, Mars would also need to be warmer. And if we managed to somehow warm the planet up, we'd also be able to release frozen carbon dioxide. At the moment, there are vast reserves of this gas at the red planet's polar caps and other areas. It would help the atmosphere to become thicker, making it possible for water to exist on the surface of the planet. Right now, there is some water on Mars. The atmosphere of the red planet is too thin for this water to stay in its liquid form. But under the surface of the planet, it's a different matter. You can find water under the surface of the planet in its polar regions. The only place where this water is visible is at the North Polar Ice Cap. Also, sometimes salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. If liquid water existed on the surface of the planet, it would make it easier for us to start growing plants. And plants, in turn, would begin to produce oxygen. But first of all, we would need to start the warming process. How? Well, Elon Musk suggests using nuclear energy to make Mars more livable. He says it could be done by creating a continuous flow of low-fallout nuclear fusion explosions above the atmosphere of the planet. It could create something like numerous artificial suns. It could warm the planet, melting the frozen ice caps, which would then thicken the atmosphere, causing even more warming. Other strategies for Martian global warming include the diversion of asteroids into the poles of the planet, or the large-scale production of greenhouse gases that could help us heat the red planet. Or we could create a giant space mirror, as huge as the side of Mars. It would reflect tons of additional sunlight onto the planet. The problem is all these projects would have exorbitant costs. They would also require serious upgrades in our technological capabilities. Could there be an easier and cheaper way of terraforming the red planet? It seems so. Casey Hanmer used to work in NASA's Jet Propulsion Laboratory. Now he's the founder of a startup hoping to create carbon-negative natural gas by pulling carbon dioxide out of the atmosphere of our planet. He's also made a proposal to terraform Mars for a modest $10 billion. Sounds alluring. So, what is his idea? Mass-produced small solar sails. These are already existing technologies, even though they appeared only recently. Such sails use sunlight to propel themselves, like ships use the wind to sail. These solar sails could be launched into low Earth orbit, and after that, they would fly themselves to Mars. There, they would reflect sunlight onto the night side of the planet. According to Hanmer's calculations, a decade of such launches could result in a 1% increase in temperature on Mars. Hanmer also believes that we could mass-produce solar cells at cell phone factories, all because a solar sail would need a processor, a camera for navigation, and some electronics to be able to transmit data, just like a smartphone. In other words, solar sails would be like small satellites using cell phone technology. Each of these sails would also need a sail of its own, a thin space blanket weighing about 2 pounds. When unfurled, it would span around the size of 2 basketball courts. Would this plan involving solar sails enable people to terraform Mars? Hanmer doesn't think so. Even if we put loads of money into solar sails, they would only make the red planet warmer and more humid, but they still wouldn't be enough to make Mars suitable for human life. Most scientists are also very skeptical about the very idea of terraforming this cold, dry world. They say that carbon dioxide and water vapor are the only greenhouse gases present on Mars, but there's just not enough of them to change the situation. Let's say we manage to melt the polar ice caps with the help of Elon Musk's nuclear technology or solar sails. And still, this ice will only release enough carbon dioxide to bring the atmospheric pressure to 1.2% of what it is on Earth. Plus, most of the carbon dioxide gas wouldn't be accessible, and we wouldn't be able to mobilize it. Even if we decided to go through an energy-intensive process of the extraction of carbon dioxide from the planet's soil, dust, and minerals, we'd still only get the atmosphere to a mere 5% of where it needs to be. Water is another problem. It is salty on Mars. It might even be as salty as the oceans on our planet. But these salts aren't what you find on Earth. If a person consumed a certain amount of them, they would be highly toxic to the human body. Who's next? On our planet, these salts are formed as byproducts of rocket fuel, as well as in road flares and fireworks. Naturally, they only occur in very dry areas. If there are no particular bacteria to break them down, these substances accumulate year after year, and their concentration in water is constantly increasing. But in theory, it's possible to purify even such water. The process of filtration could help the astronauts get rid of 90% of harmful substances. Then they could use a UV disinfection unit. This would also help get rid of any foreign molecules, if there are any, that might be hiding in the water. This stage would not only protect the astronauts, but also prevent them from bringing any dormant Martian microbes back to Earth. In other words, future travelers to Mars shouldn't have too many problems with drinking water on the red planet, but only if they bring the right purification equipment that can deal with any water quality. Because however bad running out of water in the middle of a desert is, experiencing it on another planet sounds much more terrifying. Anyway, back to terraforming the red planet. Once you start thinking about it, some worrying questions arise. Who is supposed to decide whether we should start this process? When should we start it? What if there's some form of life on the red planet, like indigenous microbes we haven't spotted yet, and our attempts to change their home will disturb them? What if they don't survive these changes? Now, what do you think? Share your thoughts in the comments.
Hey, does anyone remember the gold rush? Back in the 19th century, prospectors were flooding California rivers with a pan in hand, chasing wealth. Well, scientists now say it might be time for the moon rush, because apparently precious metals worth over $1 trillion could be hiding underneath the surface of the moon. That's a lot of money. However, can we really reach it? And if so, who does it belong to? If you have ever paid close attention to the pictures of the moon, you probably noticed a lot of holes and craters. Our satellite is like a giant Swiss cheese. It has over 1.3 million craters, if you count those larger than 0.6 miles. But today, we're focusing on about 6,500 really big ones, those over 12 miles wide. Those were not made by little green men or little green moles, but rather by asteroids crashing into the moon since eternity. Scientists compared moon scans to meteorites, and after crunching the numbers, they think there could be a fortune in platinum hiding in those craters. What's exciting is that many of these resources could be just a few feet beneath the surface. The moon doesn't have an atmosphere like Earth, so there's no wind, rain, or earthquakes messing things up. That means those asteroid crashes left their priceless metals pretty much right where they landed, undisturbed in lunar dust for millions of years. With each crater like a giant space bowl, catching platinum, iridium, palladium, and other metals. On Earth, we have to drill super deep just to get a tiny bit of these. By the way, did you know that most of the mineable gold on Earth likely came from ancient meteorites? When Earth first formed, almost all the original gold sank into the core. The stuff we can actually dig up today is probably what's left when space rocks slammed into the crust billions of years ago. So maybe you wonder why not reach for the asteroids and mine there? Well, that's because they're out of reach. Yes, in theory, it would be possible to mine from asteroids, but obviously the moon is way closer and easier to get to than any other giant rocks floating in space. We've already walked on it and brought back pieces of it to Earth, so it's fair to say we are familiar with it. This makes mining it a much smarter step than chasing unpredictable asteroids. However, asteroids are next on the list. Also, when it comes to mining the moon, it's not just about the prize. Some of those craters have frozen water. We know that because several missions, like NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1, have found frozen water ice in dark craters near the moon's poles. This ice is super valuable because it can be broken down into oxygen and hydrogen. They are the parts needed to make rocket fuel. It could also be purified for astronauts to drink, or even used to help grow plants. Imagine filling up spaceships with fuel right on the moon before flying off to other planets. Not only does that sound pretty cool, but it's also economical and convenient. That would save us a ton of money and effort. And if we're already stopping to refuel, why not stick around and set up shop? It's about building a whole new space base and turning the moon into a launching pad for exploring deeper space. A moon base would let scientists study wild space weather, practice building habitats, and test robots in real lunar dust. I can't be the only one excited for the future where robots stream their live missions from the moon. The skills and knowledge we develop there could be essential for living on Mars or exploring the moons of Jupiter and beyond. This is not as far-fetched as you might believe. Companies like Astroforge and Carmen Plus are working on tech to mine asteroids, and maybe the moon someday. NASA's Artemis program is trying hard to set up a sustainable human presence on the moon in the next decade. And Europe's space agency is also eyeing lunar resources. So yeah, the idea of people and robots working together on the moon is probably just a matter of time. Still, it's not as simple as it sounds. There are big questions that humanity faces. Just like with the original gold rush, it's a bit of the Wild West when it comes to rules. The Outer Space Treaty, signed in 1967, says no country can claim the moon as its territory. However, it's pretty vague when it comes to private companies mining resources. So, if you build your rocket and mine some platinum first, is it yours? Well, as for right now, it's a guessing game. Countries are debating and trying to figure it out before the space gold rush turns into a lunar free-for-all battle royale. Then, there's the challenge of protecting the moon's one-of-a-kind environment. Some craters are so quiet that scientists dream of turning them into giant space observatories that study the universe without any radio noise from Earth. Mining nearby could shake things up or kick dust into the air. Lunar soil could damage the sensitive gadgets and ruin the billion-dollar science experiments. That would definitely annoy researchers. Plus, some parts of the moon have been untouched, and mining could wipe out cool spots we haven't even fully explored yet. So basically, we want to make sure we don't turn the moon into a lunar construction site before we've learned all its secrets. That's why some experts suggest setting up protected zones on the moon, like national parks here on Earth, where mining and heavy machines just aren't allowed. That way, we get the benefits of lunar resources but keep the moon's most important areas safe for research and discovery. But here's an even bigger question. How is this thing going to affect us casual Earthlings who can't take a walk up to the moon with our metal detectors and explore? The moon's rare metals aren't just worth a lot. They could actually be super useful for future tech. Platinum group metals, which might be found in lunar soil, are used in things like medical gear, satellites, and even some types of batteries and fuel cells. If the moon really is sitting on $1 trillion treasure, it could boost tech industries and possibly lower costs. There's also helium-3, a rare isotope found on the lunar surface. Scientists think it could someday be used for nuclear fusion, providing a clean, powerful source of energy that doesn't create greenhouse gases or long-term radioactive waste. If fusion becomes possible, even small amounts of helium-3 could power entire cities. One cool perk of using resources from space is that we could cut down on all the digging and pollution here on Earth. That means less damage to our environment and more sustainable ways to keep up with our growing population's needs. On the other hand, all these new opportunities could create new challenges. Of course, there's going to be a cosmic tug-of-war with who gets the goodies. Nobody wants the fear of missing out on a moon rush. Bottom line, lunar mining isn't just a science experiment. It's something that could affect economies, technology, and the environment here on Earth, for better or worse. When I was a kid, hundreds of years ago, we had the moon bases on the covers of our science books. One of the reasons why moon landing projects became so rare is that it just wasn't financially viable. Why should a country spend resources to get to the moon if there's nothing valuable up there? However, now that we think there's something out there, everything could change. That's why I already imagine myself working 9 to 5 on the moon, fixing robots and growing moon plants. But it's time to get back to Earth, so to speak. Nobody's setting up a moon McDonald's or booking lunar Airbnbs just yet. Even the most optimistic experts say we're still decades away from big mining operations or permanent lunar bases. For now, most missions will be robotic, experimental, and with price tags that will make your head hurt. So until we all get our moon mining helmets, it's something to think about while moon gazing. What about that wealth hiding on the bright side of the moon? Thank you for watching.
Now imagine something so powerful that it could rip the atoms of your body apart in a fraction of a second. Ow! This something is soundlessly dashing through space, not extinct, not alive, stuck in between. If this terrifying monster were moving towards Earth, we'd be doomed. So, is it? Astronomers have found a fast and powerful space object zooming through our home Milky Way galaxy at over 110,000 miles per hour. That's faster than any rocket we've ever made. This bizarre space object got its name of a zombie star, all because it's the leftover part of a star that passed away a long time ago, but is still moving. This zombie star is a kind of an object called a magnetar, a super small, super heavy ball about the size of a city but heavier than the Sun. That makes it one of the densest objects in space. Only black holes are denser. Hey, let's not forget about me, huh? Magnetars also have an incredibly strong magnetic field. The one our zombie guy has is 100 trillion times stronger than Earth's. That's so strong that if the magnetar came close to Earth, it could wipe out every credit card on the planet just from its magnetism, and we couldn't shop anymore. Plus, if a person got too close to a magnetar, like 600 miles or so, it could pull their very atoms apart, and they couldn't shop anymore. Luckily, this magnetar is very far away and not coming near us. When it was first discovered, it was about 15,000 light-years away from Earth. That's a huge distance, so you don't get to worry about your atoms being disconnected yet. Astronomers first spotted the zombie magnetar in 2008. And since only about 30 magnetars are known in our galaxy, it was a lucky and rare find. Scientists use space telescopes like Hubble and Gaia to watch it over time. That's how they discovered it was moving much faster than they thought. Now, astronomers are trying to figure out how this zombie star got such a big kick. At first, they thought that, like most magnetars, this one was born when a giant star exploded in a supernova and the leftover core became a super-dense neutron star. According to their theory, it could have happened near something called supernova remnant HB9. That would make sense since most magnetars are created this way. But when they tracked its movement, they found that the zombie star was moving too fast and going in the wrong direction to have come from HB9. They traced its path thousands of years into the past and still couldn't find any exploding star or star cluster it could have come from. This means scientists now have one more mystery on their hands. Where did this zombie star come from, and how was it made? One explanation is that it came from a white dwarf, which is the leftover core of a smaller star like our Sun after it runs out of fuel. Now normally, when white dwarfs explode, they're destroyed completely. But in rare situations, instead of blowing apart, a white dwarf might collapse into itself and turn into a neutron star. This neutron star could then become a magnetar. This unusual way of forming a magnetar also gives clues about another mystery: fast radio bursts, or FRBs. These are very quick and powerful flashes of radio energy from deep space. Some FRBs come from galaxies that are so old there shouldn't be any exploding stars left. But if magnetars can be born from collapsing white dwarfs, that might explain how those FRBs are still happening. In any case, learning how magnetars form could help us explain many strange and powerful events we see across the universe. But so far, the investigation is still on, and no answers have been found yet. Zombie stars wandering across the universe isn't the only mystery we haven't solved yet. At one point, you might come across one of them while traveling through the cosmos. It looks like nothing. At a distance of 700 million light-years away from Earth, there's a hole, a blank void that has very few galaxies. This is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there thousands of times over. It's the mysterious Bode's void in the constellation of Bodes. Yeah, makes sense. You see, galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters. But between these clusters and threads, there are huge, empty voids that hardly contain any galaxies. Such voids make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bode's void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, I wasn't around then, all the matter in the universe was packed together quite tightly. Astronomers even thought it was something like a uniform soup. But soon, random quantum fluctuations started disturbing this matter. Some areas became denser, and their gravitational pull became stronger. They began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. If you visited a star cluster called Palomar 5, you'd forget all about voids and supervoids and even zombie stars. Instead, you'd need to concentrate on surviving, since the region is hiding a swarm of over 100 black holes right in the middle. And those black holes aren't just sitting there, they're at work, shaping the cluster nonstop. Palomar 5 is a group of stars located about 80,000 light-years away from us. Normally, clusters like this are dense and tightly packed, with stars all bunched up together. But Palomar 5 is different. It's spread out and has a huge tail of stars, stretching across 30,000 light-years. This beautiful tail is called a tidal stream. It's like the stars are spilling out of the cluster, creating a long river of light. Tidal streams like this are rare and hard to study. Globular clusters like this one are super old. Some are almost as old as the universe itself. But Palomar 5 also stands out because it's the only cluster we know about that still has a tidal stream attached to it. And the black holes inside the cluster might be to blame. They're pulling on the stars in the cluster, messing with their orbits, and slingshotting them right out of the cluster. Or would that be slingshooting? I don't know. Anyway, these stars are what make up the tidal stream. Over time, more and more stars get flung out. Palomar 5 has way more black holes than expected. About 20% of the cluster's mass is made up of black holes, over 100 of them, each about 20 times the mass of our Sun. Of course, Palomar 5 isn't going to last forever. In about 1 billion years, the cluster will completely fall apart. By then, all the stars will have been gone, leaving behind just the black holes. And these black holes will orbit the Milky Way, like a ghostly remnant of a cluster that used to be there. Even though this cluster is creepy enough, there's something even more eerie you can see in space: thick clouds of gas and dust called nebulae. One of the most unusual ones is probably NGC 2392, located 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and became popular because of its unusual appearance. It's basically a disk of material with a ring of comet-shaped objects. The tails of these objects stream away from the star at the center of the nebula. The bizarre orange streaks in the outer part of the cloud stretch light-years away in all directions. The middle resembles a ball of twine, but in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Wow!